more recently, we've been looking at how can we use LLMs to do it, and using providing the content of the problems into the LLM model, building some ontology stuff around it to do some RAG kind of learning ahead of time, and then finding some ways to validate that. And yeah, we ran this on two different subjects, an e-learning course that we teach as part of our Masters of Educational Technology, and chemistry. Chemistry, LLMs actually are pretty good at chemistry. And we did get better. I don't know if that's great, but did better. And in this case, we were actually trying just to get the LLM to match the ground truth of the skills that we had already identified. And the e-learning, which is a much more kind of esoteric topic in terms of a large language model and how it's built, we see we got about a 35% match. Again, these are getting better than our crowd workers, better than our more traditional NLP methods, but there's still certainly room to grow. So the key takeaway, yeah, generating these alternative knowledge components or skills is really, really hard. But these automated techniques, particularly with the LLMs, are starting to show some promise. It's a great area if you're looking to get into the educational data science space. That's an interesting area to proceed down. Yeah, so when we're thinking about this, we're talking about these opportunities, right? So opportunities, in general, opportunities are going to be students doing problems. So each problem is an opportunity to learn. It gets a little more nuanced, like it could be watching a video. You could consider that an opportunity. A little harder to score, like do you just give them credit for watching a video, or do you have to track? So mostly when I talk about opportunities, I'm going to talk about students doing problems. How many do we need? Yeah, this is a question I get a lot when students are building, when educators are building out new content and they want to follow these methods. Well, I always say I need 2 to make a line and 3 to make a curve. So, you know, at the very least, if I have 2 opportunities, we can see a directional thing. But really, to get a learning curve, I'm going to need at least 3. And again, it's a little more nuanced as usual. It really depends on the domain and on the algorithms that we're going to use to do this fitting. I've been working a lot in higher ed, where we tend to have a lot less opportunities per skill in things like MOOCs and online courses. And I try to recommend like 5 per skill. And we can actually run some simulations with some simulated students and generate some data and kind of get an idea. You know, in a math topic, you might need more than 5. You know, a lot of online courses, you're probably only going to get 3 on a particular skill if you have it. Yeah, yeah. We found when I have a company called TutorGen that I started about 10 years ago that works in this space, and we work with higher ed companies and work with government organizations. And we did a project with Harvard, and where they were taking their online courses through their Harvard X platform, and they wanted to make them adaptive. And you know, we went in there, and we found that they had many, many skills that only had 1 opportunity. So it's, you know, really hard to track if you only have 1 opportunity. And so we basically worked with them to get new opportunities out there. And it took about over 200 hours for them to create these new opportunities. So again, it's not the easy way out. This stuff is hard and it is time consuming, but over time the benefits outweigh what it takes to get there. So this brings us, I think Norman at the end of his talk, he was teasing on this fast and slow learner. How many of you consider yourself fast learners? No one. I kind of think I'm a fast learner, but how about slow learners? Yeah, all right, most of you guys are slow learners, wow. How many think they're medium learners? How many think there's no such thing as fast and slow learners? All right, a few people. All right, yeah, so my colleague Ken Katinger and Paulo Carvalho who's new faculty at CMU and HCI. They started actually going out, and Ken was interested in, we have all this data, can we identify who are the fast learners and who are the slow learners by how they're working through this data? And by the headline, you might kind of get, they actually found an astonishing regularity in learning rate. And I was astonished when I read this paper, and I got to see it before they were publishing it, and they were actually debating whether to put that word astonishing. This was published in PNAS, which is pretty high end, and they were like whether that was a good word. But I told them, yes, I am astonished by this data. And so what they did is they took a bunch of data shop data, and they looked at the learning rate of students, the learning rate of the knowledge components, and then they had these simulated students that they had been working on to see what, where they had predicted. And so on the bottom there is these simulated students, and you can see they had these learning rates built in. And so those showed the students learning at different way. In the middle there, we see the knowledge components, and some knowledge components are easier and harder to learn, so they have different learning rates. But my God, if you look at that top one, that's the student learning rates from the beginning to the end of the course. And all those lines are almost parallel. And that says that students are learning at exactly the same rate. There's a little bit difference over here. There's some people in this last one. But those are astonishingly parallel. I mean, basically what that's saying is students are just starting at a different learning point, right? And so, what this is saying is if you have enough opportunities, you'll eventually catch up. Now, there are some caveats. This is already somewhat split into, these are courses, right? A geometry intelligent tutor, a fraction game, a statistics online course, and an English grammar tutor. So those are pretty homogeneous groups going in, right? Those are, the students probably have some similar knowledge coming in. But still, it's astonishingly how parallel those are. And so then they continued running it on more data sets. And so up here we have math over on the left, a whole bunch. And again, very, very, very parallel. There's a few that, you see some differences a little bit in there, but that is astonishingly, students are learning at the same rate. This is really suggesting there's no such thing as fast and slow learners. So over here we have science on the top and language learning on the bottom there. And again, different learning rates, but man, the students are learning at very much the same rate. And this is surprising to all of us. I think we were super surprised at this. And the implications of this are really saying we have students who are coming in at different learning levels, and we need to be able to figure out how to get those students the opportunities they need to catch up, is essentially what we're saying here. Yeah, they're currently running this now on all 4,700 data sets and data shops. So, they'll be publishing that this summer, and it is, they're finding very few exceptions to this rule. So, I made the comment that I think this paper published last year was probably the most important education paper that came out, and in the year of LLMs, it was kind of a non-LLM paper that was this important. But I highly encourage you to read this one. If you want to, it's this PNAS, Astonishing Regularity in Student Learning Rate by Katinger. If you Google it, it'll come right up. But this is amazing stuff. So the takeaway is we need more opportunities. So how do we get more opportunities? Well, that takes us to question generation, right? And this is one thing that LLMs have really sparked and have some really useful opportunities to use large language models to do question generation. We started actually doing this back way back in the early days of large language models. When we go all the way back to 2018, there was a large language model called BERT. How many of you have heard of BERT before? A few of you, yeah. So BERT was trained on Wikipedia, so it actually is pretty good at generating questions. Google also had their T5 transformer, which came out around 2012 20. And we started using those to generate questions. These transformers, which are basically the precursors, or maybe I would probably consider those large language models. They were actually able to generate lots of questions. And so we built this pipeline. This is from my data science course. I teach a course called Foundations of Computational Data Science. And we are able to generate thousands of questions. Now, the problem is out of those thousands of questions, many, many thousands of them were terrible. And so what we really came up to is, how are we going to not show instructors terrible questions, right? As soon as we generate questions and show even a single terrible question to an instructor, they're not going to buy into this at all. So what we decided to do is really focus on metrics of validating the question. So how do we rank a list and then have some cutoff that I never show the instructor anything that's a bad question? And so we came up our initial looking at some of the literature on NLP and how other NLP things were work. We did these things like information score, did the standardization of it, and then by the time this work was finishing in 2021, GPT 3.0 had come out, and we were like, we can use that to help classify whether the question is useful or not useful. We had humans rank it as well, and trying to look at different questions and compared to experts in the GPT. It sort of kind of worked, but they weren't really the metrics that we needed. Again, we really want to have some sort of ranking of the quality of the question, so we never show an instructor bad questions. And one thing we found is there really weren't many question data sets out there. So getting a hold of people's question banks was very difficult. Even some of the, quote, open ones like OpenStax were really hesitant to give us their questions with the answers and things like that. So there weren't these really gold standards of questions that you could use for these methods. We're starting to see more of those come out, and we've actually published some in the chemistry domain and others. But you really need a lot of good questions to pre-train some of these large language models to get them to give the right questions. And again, the domain is important as well. So things like chemistry and biology, LLMs do really well on because they have a lot of data in there for those. But as you start getting into things like data science, it gets a lot more harder to get the good questions. We made kind of this pivot to, a lot of people jumped into the question generation, and that was great. But we decided to really focus on question evaluation. Like, how do we evaluate the quality of the questions? And again, this is my student, Stephen Moore, who just graduated. He was really looking at, he had started out doing a lot of this crowdsourcing, learner sourcing, and right towards the end, started moving towards using the large language models to help. And so there are these, again, more NLP methods like Blue and Meteor and Rogue, which are used for evaluating machine-generated text in more standard NLP stuff, not necessarily education. Other metrics such as perplexity and grammatical stuff can help, but as you probably know, GPT 3 and 4 are really good at grammar and those kind of things, so those are less maybe as important as some of the actual skills that are behind there and some of the pedagogical content. So we looked at, what are humans doing, and, we have IRT. IRT is great, except you need data, right? And do we want to give students really bad problems to collect that data? I mean, we can, but we'd probably rather not give students bad questions. And it's also time-consuming. Having humans review them, especially instructors, also, that's probably the gold standard, but also very time-consuming and expensive. A lot of subjectiveness in human evaluation. There are these rubrics, though, and so one, I don't know, has anyone heard of the item writing flow rubric? That's one that's out there. There's a few different versions of it, and we found that to be actually probably the best way to go. And there's a couple of different writing flow rubrics, but we chose this 19.1. Here's like 4 of those points. And things like, is there a grammatical cue? And here's a question over here. And you can see in this question, there's no period at the end of C, so that might be something that would be a cue. And then the convergence cue is where the word subatomic is showing up twice. Logical cue where subatomic's in the stem of the question and also in some of the, and then like an implausible distractor, which just doesn't make sense, right? That distractor. And there's 19 of these. I didn't put them all in here, but you can look it up. And so then we were trying to see, could we use crowd workers again to explore and apply these rubrics? We also looked if they were able to kind of do a more simplified Bloom's level of taxonomy, whether it was a recall question or an application question. Could we have crowd workers identify? For the item flow rubric, the crowd workers were great. They actually did extremely well compared to the expert evaluators that we had, and very much matched what we saw. So the crowd was good. We also paid very well. We used Prolific, and we paid at least, I think, $12 an hour. Some of this, we went up to like $20 an hour on some of the things. So, it turned out to be fairly expensive for us, and maybe not worth the effort. So we really wanted to see, could we use automated methods? And I probably should have flipped these. We actually started out with LLM, trying to do LLM on all of these, and then we actually went back to some rule-based methods when the LLM methods weren't quite as good as we thought. Thinking about whether or not we can use these automated methods, and so we did 200 questions times these 19 criteria. It actually turned out the rule-based methods worked better than the LLM methods, and we actually started with the LLM, and we weren't getting as high as we thought, and so the 91 and the 79 are on those individual points, the matches, and then to get the exact match, so for all 19, we got 15 and 12, but interestingly, humans don't match very well on the all 19 as well, so if you have 2 humans apply the rubric, it's a little bit better than those, but not much better. So we found that applying these automated methods was very scalable, especially in these were multiple choice questions that we looked at. We were able to kind of level out which ones where they fit on the Bloom's taxonomy as well. Surprisingly, the rule-based did better than the black box LLM type methods, and they also were very easy to interpret. So GPT-4 did well on some of those. So the question was, could we combine the methods? And so we start looking at how could we bring this all together? And actually, this is kind of the last part of my student's dissertation. He built this automated toolkit called Socket, and it actually allow you to put a list of questions, and these can be any questions. They don't have to be machine generated. They can be human generated. They can be your existing question, and it can actually look at them and give you some output on there and do match to these labels on the writing flow. And with the combined method of the rule-based and the LLMs, we saw a little bit of uptick where we were looking at 15 and 12% on the exact match, and that's now up to 38, and I think we were at 90, 91, I can't remember. Now we're up to 94, so seeing some increase, this combined method, that kind of makes sense. We're ensembling things and getting better. So pretty good. Getting close on where I wanted to stop, so let me go through, We should be getting better, yeah, so LLMs are getting better. We're hoping these methods will improve over time. But yeah, we feel like we're getting really to where we can evaluate questions now, and that's really important. Again, as we see, we need these opportunities. We need lots of questions. So yeah, still some opportunity, especially to get some deeper level questions on the Bloom's taxonomy. Our socket is showing good interpretability and good fit on there. And yeah, we as the LLMs have gotten better, we're expecting to see improved accuracy as well. All right, I kind of want to jump really quick on a whole different topic on adaptive experimentation. So, you know, how do we validate these things that we're learning? We've been very interested in running experiments. How many of you guys run experiments? Most of you, I hope most of you, yeah, in academia, we should be running experiments. We've been looking at how we can scale experiments, how we can do it faster. I think we have this quote that I'm attributing to Herb Simon. I don't know if he exactly said that, but every classroom is a laboratory. And maybe Norman, did you say this as well last time? But I'm taking credit for it. Every course is actually a series of experiments. So you may think you don't want to run complicated experiments in your course, but you're actually running an experiment. You're making a hypothesis that the activities that you're giving, in the order that you're giving, are the best learning, going to give students the best learning. At least I hope that's what you're doing. But yeah, you're making this hypothesis out that this is the best learning activities and the best flow of giving the students the best order of those activities. And so I would argue that we should be doing some experimentation in every course that we run. And so we've been trying to figure out how do we make that easier. And back in 2022, they started this Digital Learning Challenge X Prize for $1 million. And the idea was that you would run, it was sponsored by the US Department of Education, and you would have to run large-scale experiments multiple times in a very short period of time. You had to run an experiment and then rerun it within like 3 months. And it had to be what they considered a large-scale experiment, which they really didn't define in the thing. But because we had the Open Learning Initiative, we had access to these 600 universities that were using courses. We were able to actually run this, and we implemented these adaptive experiments, and we actually wound up winning. So yeah, didn't quite get $1 million, but CMU got some money. I haven't seen that personally. Yeah, so what we did is, we had a traditional kind of random control trial, right? That's our gold standard. And we were interested in, the experiment we were running is, does self-explanation, adding a self-explanation prompt to some of the content improve the student outcome? So yeah, it was, we would give them a little box where first we'd ask them to explain, and then we would ask them a question in the treatment condition and the control condition. They didn't get the self-explanation prompt. Similar stuff has been run, and we kind of know that self-explanation should help, and it actually turns out that it did. But with a traditional random control trial, we would typically do some allocation of some uniform random. The top one would be like a 50-50 allocation where 50 go to A and 50% go to B. If we kind of have an idea, we might do a random control trial with a different than 50-50 allocation. We also might have more conditions, right? We could have 3 or 4 conditions. We could have 100 conditions. But we would run everyone through on this and then make the results. Well, taking some inspiration from what's been going on in kind of the UX design space in HCI with the big kind of FANG companies of Facebook and Amazon, they're running these adaptive experiments where they're giving really small changes to their interface, and they'll run it out and maybe do 100,000 or 1 million trials within a couple hours. And we were wondering, could we do something similar? And because we have the scale with the Open Learning Initiative, we thought we would be able to do that. And so, you know, I'm not going to go too deep because I do want to get done here in a couple minutes. But, you know, basically after each, at some interval, it could be every person who goes through your experiment, or we actually ran it every day. We would kind of compute, you know, how the conditions were running. And then you get to, you build a distribution each time, and then, you know, here's an example of an experiment with 3 conditions. At the top would be your traditional uniform random, where each set is getting the equal number in each of the conditions. The bottom is an adaptive experiment where things change over time. And at the beginning of the experiment, it may be really, really choppy. So sometimes you'll even run a more traditional experiment for the first X number of participants and then start adapting it. But you'll see, you know, it'll start clearing out, and the condition, in this case B, seemed to be the better condition. And so eventually you're getting to the point where everyone's getting thrown into the B condition. From a psychology perspective, is this valid? I don't know, we can argue about that. I tend to think if we can run these experiments and create a method of making them easy to run, where people can just plug them in their existing course and make it you know, more seamless than it is. We're not quite there yet, but our idea is that if we can start running this on pretty much every classroom, have at least one experiment running in it, we can start really validating a lot of different things. I just want to talk about a few other projects that I'm working on. I'm doing some work in Uganda with Amy Ogan, who's faculty at CMU, and a company called YIA Air Science. We're using texting phones to reach kind of the really, really rural folks in Uganda. And yeah, there may be some interesting stuff here for you guys, because we're running some studies right now where we're looking at instruction in the local languages and in English. In Uganda, everyone teaches in English. It's very uncommon to have any kind of schooling in the local language. So, but it also turns out in rural Uganda, their teachers don't speak good English, the students don't speak good English. So we're trying to see if we give them instruction in their local language, does it help? Some social issues with that as well. Again, students are expecting to learn. Doing some stuff with hidden feedback generation. I got an award from DARPA, which is the Department of Defense. They wanted to see chatbots. I'm not a big believer on these LLM-based chatbots. We've been doing chatbots for 20 years in learning science, and we don't see them ubiquitous in intelligent tutors, so I'm not sure how that's going. But this is some of the work that Norman also showed, where we're integrating a little chatbot into the Open Learning Initiative. Let me, one quick thing on this one is what we have found is that a quick takeaway is students don't know what to ask a chatbot. So we do need some pedagogical scaffolding. So we've been working in the computer science space of adding some pedagogical prompts, so trying to determine if the student really needs a planning question, or they need to ask a debugging question, or do they need to see a code snippet, or do they need to see a worked example, and trying to get them to prompt that way to say, you know, I'm planning to do this, or of course students don't like the extra work and just post it into GPT on the side and just get the code is what they really want to do. Also doing some real-time, what we call real-time knowledge sharing. This is with the US Navy, where we're taking training videos and trying to understand what skills are in training videos, and seeing how we can identify and improve the skill models from training videos. Kind of an interesting thing. Yeah, just to end it out here, I would say, yeah, with the LLM stuff, let's not throw away 25 years of learning science research for this shiny new toy. I saw in the last few years, I've seen so many new intelligent tutors that are built on just kind of pretty straight prompting in LLMs, and I'm skeptical. Yeah, but we do have this data, and data, you know, 10 years ago, we were talking about how great it was we were generating all this data. We haven't made that much progress on using it. So we really do need to not just jump to this zero-shot, one-shot stuff with LLMs and really think about how we can harness the power of data that's out there. All right, that's all I have. Thank you.
Thank you. Thank you, John. Yeah, so maybe we can take just one question.
Okay, sorry.
Anyone? Any questions? Yeah, Viraj. And those who have their paper presentations and chairing the sessions, sessions, please start moving to the respective rooms. Please, Viraj.
Hi, John, thank you for the great talk. Viraj Kumar from Indian Institute of Science. So just a quick question regarding these cases and the specific questions you had. My sense, please correct me if I'm wrong, my sense is the questions are in some sense very pure. They're just focused on that one KC. Especially in higher ed, we tend to ask questions that are testing many things, and does that become impossibly hard to produce learning curves for, or is there some way to?
Yeah, so it's definitely not impossible, and we see many cases in higher ed especially where we do have multi-tagged problems with multiple KCs. It does make the learning curves harder to interpret. So, but from a statistical model, we can absolutely look at that. It just doesn't make as nice a picture as my geometry area.
No, but you could disentangle per
Yeah, you
KC.
can disentangle those, and you can see it. Yeah, and we have many like that where we have maybe 4 or 5 KCs per problem, and it does work. Yeah.
Thanks.
All right, maybe
All right.
we can have one more question.
And I'll end with this too. Here's a Bayesian prediction on what I asked in the very first slide. And it turns out it would have a 99%
Hello.
mastery.
So,
Yeah.
In the slide number 24, suppose you talked about BIC model. So here, how do you took the heuristic data? How do you set that value? So is there any specific method? How can you set the heuristics in that model?
How do I say? Well,
For the BIC model, Bayesian Information Criteria model you talked about, yeah, how do you set the heuristics? Is there any criteria or setting standard to reach the goal?
I'm not hearing the question.
How do you set heuristics?
Oh, what?
How do you set heuristics in the Bayesian
Oh, okay,
model
yeah.
that you talked about?
So here's an example up here of some statistics. So with a Bayesian model, we have things like transfer. The P else of 0 is where we think you're starting, and the probability of guess and probability of slip. Traditionally, those have been set by psychometricians or cognitive scientists. I would argue that, yeah, you can set some initial values, but you can go back and fit those as well. So collect some data, and then you can fit the models that way. That's the best way to get the parameters.
Okay. Thank you.
Yeah. Thank you, everyone. Let's thank the speaker for the wonderful session.
Oh, okay. Thank you.
What kind of consent do you ask for from the students?
What about how we ask content?
Yeah, consent.
Oh, consent. It depends on experiments, but with the Open Learning Initiative, when they enter the first time, there's a consent form, and so we have a blanket IRB.
Yeah, and there is a change of schedule. We have announced it. So the next keynote will happen in the same hall at 11:30 a.m. So please refer to the updated program schedule for today on the website.